Over to Roman Paparov, and he's going to talk to you about scraping some NHL data. So, welcome.
Good evening, everyone. So in previous countries that I participated, I sort of went to something where I completely layman, talked about models, stuff. This is something that me as professional sysadmin, it's close to heart. It's just getting some kind of data, reverse engineering a little bit. We'll see how we can get all this nice data, and we'll also see how we can parse it, store it, validate it, and make it ready for the wonderful uses that are going to be shown in the next tutorial. So let's start. We'll ask and try to answer the following questions. What data is there? What types of data does NHL provide publicly? How that data can be retrieved, how it can be validated, how can we store it, and what can be derived from that data in some simple way. And we'll talk nothing about web development, model development as well. So to make sure we're on the same page, I'll go over this small glossary. So when we say crawling or scraping, talking extracting data, pure data from the web pages, shading aside the layout and design. When I say HTML, hypertext markup language is the format of the language that is very popular to build web pages. JSON, JavaScript, object notation is a very popular format to exchange data between applications. XML, extended markup language, is a decreasingly popular format to do that as well, but due to certain constraints and very heavy specifications, it's sort of getting less and less popular. The acronym API stands for Application Programming Interface, and it's some kind of protocol that is devised for applications to exchange data. The acronym CLI is a command line interface, because if you want to get some data in some kind of automatic way, you need to have a tool that will run by itself from sort of command line or even absence of command line. XHR, it's a second level acronym. It's an XML HTTP request. It's a mechanism, it's a technology to refresh a part of web page without actually reloading. And Perl, it's a programming language which not many are now unfortunately familiar, but me being the dinosaur I am, for 25 years I've been using it. It used to be very popular, and why I'm mentioning it, because that's what I am using. And the few code examples that I will show will be Perl examples. Don't worry, I think it's pretty understandable, contrary to the reputation of the language. So the tools that we're going to use is the web console extension of the browser. I recommended to use Firefox because I know exactly where web console is, how it works, how to extract data from it. But as far as I know, Chrome also has a web console, and maybe Explorer does. We'd like to use a JSON viewer extension so that every JSON data that we try to analyze will look nicely, not like just one long string beyond any understanding. We'll use CURL, curl. It's a command line tool to get web pages. The alternative is wget. Wget that once it was more popular, now CURL is more popular. And there will be a few excerpts that are related to MongoDB, because that's the storage engine that I'm suggesting. There will be some protocol snippets, as I said, and there will be some command line interface commands that I will show how to execute. And this is a warning sign because Perl is associated with Camel. It's the O'Reilly publications. They publish some kind of books on programming. It's all serious, and they assign an animal to each and every topic. So Perl goes with Camel. So let's get into the actual stuff. So we have many data sources. In fact, we have NHL.com. There are some news websites that publish sports reports. The lists here are not complete by any means. There are online databases that already do that job. National Stat Report, ETV, Elite Prospect. There are commercial sites that have their own data. The fantasy sports websites have a lot of data on the games, on the players. And there are even some dedicated sites to particular topics that may or may not be familiar. We'll concentrate on the primary source, on the NHL. So scraping is effectively a reverse engineering. You look how the page loads and figure out what you can get from here. Why wouldn't we switch here? Some reason it seems to start with output. Yes, so here we have with the web console open. To open the web console, you go to Tools, Web Developer, Web Console. And if you take a look at this is the scores page of NHL. Now, in this row, the web console, laser. So you should disable all these errors, warning, log, whatever, only leave the XHR shaded. And this is from yesterday. We reload it. You can see that there are 3 XHR calls. And these are actually, the page loads and then you see the circle spinning. These are all the XHR parts loading. And what is of interest to us is this line. That's API web NHL.com, API v1 schedule. So this is what happens. The page calls by itself the API, requests data about schedule, and it's also send the start date, the end date, and also some extra information of what to bring with it. And this call can be executed directly by us, say through the web browser. So I already did some cut and paste for a call, which in this case I only took the dates. And change them. And in general, you don't need anything back, but basically you want to get information about the schedule. And if I reload it, so show that it's not staged, we get this structure, which is a JSON. And you can see how many items, that means how many games are on this date. Or if you request a range, then within the range. And then there is a structure of data that describes what is going on each date. So you have date, which is the 15th. That's actually for today. And then we have information about games that happens on that day. First of all, remember this kind of number, 10-digit number. This is an NHL game ID. This is how every game in the NHL is stored. It's constructed of the season with the starting year in front. The exception is the season 2012-2013, which had lockout. It started in 2013, but it was still referred as 2012. Then we have 02, which indicates the stage. 01 is preseason. 02 is regular season. 03 is postseason. And then there are special stages. I think 04 is for all-star games. And beyond that is for international competitions. For example, I think the last World Cup had 06. I'm not sure. We have some information about the game. This is something that's going to come up later. It's information about game live. So this is the season, the date, and but this particular call is mostly useful just to get the schedule, just to know, okay, which games happened on which date. In general, if we put here, let's say, September 1st of the year, and here we put August 31st of the next year, we'll get all the games for that particular season, how they're scheduled. Now, in general, if you want to get this list, keep this list up to date, you need to do it regularly because games get moved from day to day because of weather and other circumstances. Feel free to ask questions at any point throughout. Okay, let's go back. In this screen, I want to show more of these XHR calls. You see they refresh. They get issued all the time. If you click on Game Center for that game, we get the page. Go over here, the header tells us the story of the game. There is a box on the side. But once again, we can see quite a few XHR calls. And you can see this one. This is the information about the game itself. Once I don't also this is so this is the live feed of the game. This is mostly what most of the live data feeds come from, both from the NHL and from the other sites that you see, and from the automatic Twitter posts that you see. Has a lot of data about the game. It starts with game data and times of the game, and then the status of the game. The final means the game is over. It can be a preview, it can be live. The information about teams, the level of franchise. can record this team as current team or as a franchise. I will not go deeply into the structure of this JSON because it can take a separate tutorial. Then there are players that participate in the game with some brief information about them. There is information about the venue. And then we have the live data about the current state of the game. This information about periods. Then there is information about, and then the interesting thing comes, which is the event. The order of the fields in JSON is arbitrary. You don't expect that something will come earlier than something else. So all plays means all the events that happen in the game. So first there is some kind of metadata about the event. There are events which say, okay, we're ready to start, some formal events. Period ready, period start. And then we already have a real event, which is, we see the participants of the event. And we see the type of the event. And we also see how the event developed. Basically. And then there are all kinds of something like 15 types of events, from play events, from goals to up to the recent addition was delayed penalties, and also some non-play events such as stops and period start, period end, video reviews, challenges. So this is how we actually get this data. We see the XHR calls. We use the weapons assault to fish them out. Then we try to understand the structure of the call. And then we get the data in its pure form, shading all the layout aside. So the data types that are provided, this is an incomplete list, and I'm not using them all myself. We have the API feed, which is the schedule feed. There is a player feed, you can get information about players. Let me show this one too. So the resolution is here, a little bit lower side. This is the player page of Andrei Svechnikov. And once again, if we reload it, okay, so once again we have this API call. It brings us information about player, both his biography and his career. So it looks like this. First, there comes the biography, where he was born, the country, the date, so on and so on. First player has been born in the year 2000 to play in the NHL. Then there is his position information. And actually, this position might differ from what you usually expect. So, and the other thing, it changes and doesn't keep history. So, if you go to Brent Burns, you would never know he was a forward in his career. That would be here. And then there are stats, season by season. And it not only shows the NHL, but it also shows the available statistics from other leagues. So if you're interested in them, you can observe them as well. If you're interested in the NHL data, of course, you can discard. Do you see it well enough? Should I expand the slideshow? So, schedule players, games, there is an API for shifts. There is some nice diagram that you can get the shifts in the game, and this is fed also by JSON from the API. The API for the draft, it's of course data that's produced once a year and stays static, but you can extract grammatically all the players that were drafted. And there is, interestingly enough, there is an API for situation room, and I'll get to it later. The site, it sort of stands by itself. The other thing that there is the pure HTML report. And if we go back to the game, and I'll scroll here all the way down. There isn't much space, but there are links. These are reports. These are HTML static pages that also have most of the information from the API, and sometimes information that the API doesn't have. So they sort of, I don't know how NHL manages the data, so that it's sometimes just really out of sync between one another, and you have to match it if you want to combine. So I opened each type of the roster. This is the sorry, of the report. This is the report for the starting roster. We can see that there are 20 entries in each list. It can be less. Sometimes when the club doesn't have enough space to address 20. And in bold, there are starters. In italic, there are letter bearers. And this is something interesting, that if you decide to poll to this page, because this address, the address for each game never changes. It always has this prefix, then the season, who, and then the type of the report for rosters is RO. Then the number of stage that I mentioned, 02 for regular season games, and then the actual game ID 0286 is in here as well. To poll it repeatedly, at first there will be nothing. Then there will be some preliminary sheet that contains many more than 20 players on each side, and without indication of who's starting, who is not. On the bottom you can see some scratches as well. And there might be nothing in there. So that's some kind of, that's probably following some NHL protocol when you have to publish some kind of generic roster, and then around the time the game itself is scheduled to start, but not actually starts, let's say 7 p.m., these are published. So 7 p.m. is more or less indication when these precise rosters are being published. If any of you follow me on Twitter, you might notice that I published some kind of prognosis on the games updated by roster. That means that I catch this moment, and then I publish the output of my model according to exactly who is going to play, who is going to be involved. I think that's a useful thing to do, to know exactly who's playing. The next report is enormously important if you want to learn what actually happened in the game, is the play-by-play sheet, where we have pre-game start, pre-game end, anthem, which are not really interesting, and then after period starts, we have face-off, and then we have all kinds of events going one after another, with description, which is more or less in a strict parsable finite format, that also contains the distance of the event from the goal from point of view of the attacker. The API contains the exact coordinates, so they match. This one is consistent. And also we have on-ice presence of players for each event. We can see the numbers, and we can see their positions, and if we hover over it, we can see that who it really is. And this list goes on and on and on, usually between 250 and 350 events per game. Until there is something, in this particular game went to overtime, so effectively the goal ended it, although there is probably Rasmus Ristolainen wasn't happy with the outcome and the game misconduct. We have period end and game end and the report end. There are more reports, I'll show a couple more. So this is the event summary, which shows the cumulative statistics of players for the game, not for the goalies. The goalies are in a different report, don't know why. Probably because the NHL didn't want to alternate the columns. So there is a shot summary, face-off summary, and then there is team summary for the away team and team summary for home team, and the legend below. This one event is useful for mostly for validation of data from other sources. Complementing it is the game summary, which is reminiscent of the old HTML, old NHL box score pages that people remember with the dark background. So this is a bit similar to it. We have the goals in order, also the on-ice players during the goals. We have the penalties. We have some by period data, by strength data, and then we have the goaltender summary that was absent from the previous report. This is information. This is these are sheets of timesheets, clock in, clock out, and with events. This is also a table which is very easily parsable. And we have a separate file, TV, team visiting, and TH, team home, but structure-wise they're identical. Also, there is a report for shootouts, and which I didn't bring, but there is a report on face-offs. These are statics, and as far as I know, they don't change once they're issued. So if they can have some errors, they will carry them over forever. Of course, those who want to really dig into building finite automata and try to parse the HTML of Game Center. Actually, at some stage, the player API didn't return the correct information about the draft of that player. So one of the ways was to load the full HTML of the player page that we saw and extract the data from there. First of all, you can extract the list of the games, or you can go to the earliest starting game and just click on the link that I don't have here, and just launch it. Never mind. So, but it has export. You can export by directly the CSV of all the players, and it will have the column for injuries. And I think I have it somewhere here. Said some command line to be used. That has injury status and starting. So for the goalies, here we can see that Yaroslav Polak is not starting and Karaskis. This is a nice compliment for those who are trying to predict outcomes of games. So just a little bit of how it looks in code. We have the URLs program here. There is an extra one for schedule because for the whole season there is some simpler way to get the extraction. Now, all these reports that I showed, they exist from the year 2007 on in this format. Some of them before, some of them appeared in 1999. First, there was the game summary and the event summary in 1999. Then the play-by-play 2002, and the roster reports and the in 2005. And I think the shift report is only existing in the current format. So before that, the format was completely HTML format was completely different. And so if you want to parse the other data, you need to write a different parser. But the API exists for all 100 plus years of the NHL. You can query the games from 1917, 1918 season, and you get the results with one exception. Interestingly, I don't know, probably because of legal situation, when the Stanley Cup finals, when they were involving the teams from PCHA, they don't have any data of players that that didn't play in the NHL at any stage. So the players from the Vancouver Millionaires and from other teams, from Seattle and Portland, the players that never played in the NHL, they just don't appear, as if they didn't score goals, as if they didn't exist. So I don't know why. I think the reasons are purely legal. So we have the HTML report template. We have the player API template. We have this direct link to the player page, which I use. This is the API for situational room. Also, these are more or less standard formats of C and C-like programming languages. And this is sort of excerpt, an example how I get data from the live feed, which is we get it. So the game is substituted, the game ID is substituted here. We get it, and then we create some kind of object with the JSON that we obtain. I also set some extra ID data, and then I do some validation. If, for example, if I know by heart that this JSON was broken historically, then I have some information about it, and then I just say, okay, validation didn't. Validation is okay because we can't just validate it. Let it go as it is. We return 0 if we couldn't figure out, couldn't parse the JSON we received. And if there are events in the box score, we say, okay, if it was good enough to parse and good enough to find events, then it's probably okay. Now there are some JSONs that will miss data. In this case, that will raise a flag that's something strange. I'll get to that later. So, as I said, so we can fetch it in browser. We can fetch it using the curl, putting the same URL that we put in the browser window. We can give it as an argument to curl, and it will fetch it. Same about HTML. This is the Yahoo data. Of course, if you want, you can fully integrate with their API service by registering as a developer and using their OAuth 2 authentication system, but I think it's out of scope for the current tutorial. These are the URLs for Yahoo. What is, in my view, as best fetching sequence? So we need, first of all, to fetch the schedule to verify which games are today, the games were moved. Then if you want to, we should get the injury data. Then we pull for the rosters until they finalize. Then we monitor the live feeds. By the way, the HTML reports that I showed, at least play by play, is also updated all the time. So you can pull for both. Then when the live feed is complete, we got it. We can now gather all the HTML reports. And maybe we'll return in a couple of days to see for error corrections. And one very recent example was that in the game between the Maple Leafs and the Black Holes, the 4-5 game, where Austin Matthews recorded 4 assists. If you would look at the events themselves, the goals would be one assist would be attributed to Andreas Johnson, and if you would say, okay, let's calculate how many assists are by goals, Matthews will only get 3, and Johnson will get 1. But in the stats, in this aggregated box score, you will see that Johnson has 0 and Matthews has 4. And then that was correct. So you might want to return this grade. Now about reading and parsing. So first of all, so I maintain myself, if anyone wants to see how the real code is, model on CPAN, which has all the reading and parsing implemented with Perl. You don't have to use Perl, but you can at least see how one crazy person does. And in general, the JSON is easy to parse because you sort of, that JSON library, third-party libraries, and just feed the string and it works. And the HTMLs, yeah, it's not easy. You have to do something that is that knows how to parse. In Perl, there is something that's called HTML tree builder. It makes everything look like a tree, and then you traverse it and extract the strings between the HTML tags and get the real data. And one more, I see that I'm behind the schedule, so I'll speed it up here. So the structure and the dictionaries of the documents change. The HTML changes. The NHL optimizes their own mechanism. So, for example, here I wanted to show there is a different wordings of penalties that NHL could use for the same penalty. So delaying the game has 5 synonyms. Well, parse it by name. There is no code for it. Then, what I think is must to do is to do some kind of validation. First of all, that the file is complete, that the game is final when we want actually to insert in the database. Then there is syntactic validity that the game, that everything looks like it should look, and this is something that happens a few times. Happened. Apologies. You see this? This is not a real time in real date. This -16 colon 0 minus 1. This crashed a lot of places. Not only mine. I know at least 2 more crashes. And it repeated again. It didn't happen only once. Sometimes some fields will be just missing as well. So, of course, we should check that the lineup is consistent, that it's 18 plus 1 plus 1, that it's the players that are playing are in the roster and it's not the scratches. Recently, this data is very consistent. If you take some data from 15, 20 years ago, you'll get flips all the time. Event consistency, you can sometimes see shot block by a teammate. You can see 2 goalies on ice at the same time for the same team. Sometimes the shootout order is messed. You can see 2 players from the same team would be recorded consecutively. Then there is numeric consistency, like I told with the recent game, Toronto-Chicago game. There are penalty issues for consistency as well. Sometimes the person that's serving the penalty gets the penalty minutes assigned to him. Sometimes it doesn't. And I have a site, I run a small site which is called NHL errata. And see sort of these are events, for example, that were in the play-by-play HTML and weren't in the live JSON. These are some kind of broken feeds that are just out of the sort of the data here. These are the games against the PCHA teams. You can't really understand what's going on from the feed because the events that involve only PCHA players are missing. Then there are some there is a map. Some events, for example, the file for this game and the file for this game actually both points to this fact. This is a big list of systemic errors that I compiled. And this will not take time for a break. So, just an example of validation. So this is, for example, testing if the penalty that we read is something that is defined with the vocabulary, and we see that if we already know that this penalty was incorrectly defined, then I have a file that has all the correctly defined penalties, and if it matches the vocabulary, like I showed you, all the synonyms. Once again, if there is something new, a new definition, this very season, there was a goalie, the event goalie stopped changed from that to goalie stopped after shot and goalie stopped after pass. So you have to chase it all the time, and the length of the penalty must also match one of these. And yes, 3 is okay because the all penalties were 3 minutes long. A quick word on storage. I want to store this data. Files are okay. I store the files in a format like that. SQL is a popular database, method of storing database, MySQL, PostgreSQL, Oracle, whatever. But the data is often not tabular. Yes, for events it is, but it's more like a crossword. And it's not normalized. So you have to do it once again. So I suggest that everyone who wants to do it use some kind of non-SQL database. I use Mongo, which is very convenient because you can grab the JSON and just drop it into there. Or if you parse HTML, have a data structure, you can just drop that data structure, convert it to JSON. And then you don't have to normalize. And it's really, really convenient. And I wanted to show a little bit how it can be used, but I don't have time for that. So I'll just, this is how I do, how I get my data. I merge all these HTMLs and JSONs into one data structure, normalize it in some way, it means that the synonyms are merged, and then I populate the database. So from, if you want, you can use later, this is how I have some API and query the Mongo database that I have, and the examples are in the slides, so you can do it later. And just a very, very quick overview of what can be done with data. So, for example, you can gather statistics of ring repairs, which rings are getting repaired more. There's a stock event called ring repair. Yeah. We can detect who scored NHL goal against which team and which goalie. You can detect offsides, because there is a stop calling offside, there are coordinates for the next phase of event, and then you can see which side of the red line, the face of the place. You can even take, so prior to 1997, the penalties were not telling who against who, but if there are two fighting penalties at the same time, obviously these two people fought each other. You will take away statistics, roster talent, because okay, you have all the games, all the rosters, and you know which draft pick, which everyone learns about. So you can see how much of the roster talent each team used. This is only information. I was asked interesting questions, so with this data, like the different players of this in goal, assists, and points. There was a 200 goals lineup challenge. Goals by defensemen assisted by two other defensemen. Mostly when a defenseman comes out of the box after penalty and scores a breakaway goal. Hat-tricks in consecutive game against the same team, feature only managed by Brett Hull and guy forgot the name, 1922. Longest point streak by a goaltender happened 3 point streaks. There are 2 of those by Barasov. Fastest team to finish the playoff burst. All kinds of questions you can suddenly answer. I'll skip this. So once I wanted to do statistics of challenges and video reviews against which team they went and didn't go. And then I realized that some video reviews were missing. And I had to go and find that API to particular situation room event. And this is free text. This was a fun parsing, but I sort of made it. Not in my database completely yet, but almost there. And just a little bit of fun here. This is standing density over years since 1967. Seasons. But these are primitive things. The real things will be in the next tutorial. That's it. Thank you.
I think we got about 5 minutes.